So today what we're going to be focusing on is, again, continuing stoichiometry, but really developing our molar roadmap. And my goal is to, one, be able to give you the map effectively, make sure that you understand what your requirements are for the map, and then also to go over just a bunch of practice problems that cover this topic. We started this a little bit yesterday, so to remind ourselves, we had moles of A on the left side, and we had moles of B on the right-hand side. And I had drawn a connection point between the two. And what did I say about that? What did I just draw this out yesterday and that was it?
Sir, when you said that, I watched the recording and it says that there's one connection, signifying one step.
So yeah, one connection's one step. And did you write anything else? You wrote bottom and top. So let's remind ourselves B and then T for bottom and top. And today we need to add in a little bit more to this. So the new pieces for today, one right there and one right there. And it would make sense that we need to put in our roads, so there's our roads, correct?
Would that be 4 steps or 2?
This would be a total, if it depends, if you're having to go from the mass of one to the mass of the other, this would make a total of 3 steps. Now if you're going from mass to moles, this would make how many steps? Only 2. Not only do you need to know that there are roads, but you also have to know the names of the roads, so I'm going to give that to you real quick, and watch closely. If you're going from mass to mole, I think you should work on dividing by, that's a division sign, divide by the molar mass. And if you're going away from the mole, then you need to multiply by the molar mass. Let's think about it. To go from home to school and then school to home, you typically take the same road, correct?
Mm-hmm.
Are you going the same direction on that road?
No.
You're just going opposite directions, but it's the same road. The name of the road here is molar mass, it's just you're going opposite directions. Make sense?
Good enough.
Thank you. You'll notice from this side over here on your left that you divided by molar mass to get to mole. So since I'm going to mole this way, I should be dividing by the molar mass. What would I do to go away from the mole to the mass? Multiply by the molar mass. Hopefully what you have seen here is that these two sides are just copies of each other. The difference here is that this is about compound or substance A. The right side is about substance B. Make sense? You at least see where this is going. So, let's start this off. We'll go over an example. Are you ready? And I'll get you to copy this down real quick and then we'll discuss it. Off to the side, I think it would be beneficial for us to start this problem by jotting down the map, or at least a little mini map. Think about it. When you're going to make a venture or a travel to, let's say, Austin, which is a couple of 100 miles away, do you write down the entire map of Texas to get you there?
Nope.
No, you only print out or you only write down the part of the map that would be applicable to that travel, correct?
Mm-hmm.
Okay, so remind me real quick, where are we starting at here? What's our starting amount? I'm sorry, what?
478.2 grams
Of NH3, correct? And what are we going to? Of what?
and
So here's, I think, a strategy that I want everyone to try. Underline once where you're starting and twice where you're stopping. That might really help us work through the problem. Or you could just underline them both and draw an arrow, or combination of the two. But I want you to make sure you understand that you're starting in Richardson and you're traveling to Austin, and not the reversal. Good?
Mm-hmm.
Now, looking at this map from above, we're starting with the mass of NH3, correct? Which is this point right here. So now I would just write NH3 instead of A. And where am I stopping at?
And
N2, which is on this side, correct?
yeah.
And am I stopping at mass or moles?
Moles.
How do you know it's moles?
It says how many moles.
How many moles? So you know to stop there. So here's what we're going to write out. Mass NH3 down to mole NH3. Then over to what? Moles of what? N2.
Nitrogen.
Now I want us to make sure that we're very clear on how I was able to get that from reading this problem and knowing my map. We set? Started with mass of NH3 and I'm going to moles of N2, just as the problem said. Why did I not take this up to mass of N2? Why not go there? It just asked to go to the moles. It did not ask to go to mass. Okay. How many steps do you see here?
1.
I see 1 there, 2 there. So that would be 2 vertical lines today, correct? Now let's figure out what our roads are. According to my chart from above, what do you do to go from mass to moles?
478.
What do you do to go from mass to moles? Chart above, right here. Divide by what? So I'm going to write out divide by molar mass. Now what's the molar mass of NH3? You'll need to take your time and calculate that out real quick. Everyone will need out their calculator. Something like 17.031.
17.030.
Close enough. Okay. Then what did I write over here to go from moles of NH3 to moles of N2? What? You're supposed to do B then T, right? So what's going to go on bottom here? Moles of NH3. And how many moles are we talking about according to our reaction? 2. How do we get that 2 moles of NH3?
I thought as the coefficient.
Coefficient. How many moles of N2 are we talking about? 1. How do you know that? Not a number written there, so it's understood to be 1. So let's put this in our dimensional analysis chart. What number's got to go in that top left box?
478.2.
The number they give you always goes in the top left box.
2 on the bottom.
Okay. Now in that first step, which is right here, I said divide by 17.031. Is division top or bottom box?
Bottom.
I'm sorry, what?
It's on the bottom.
So division is always on the bottom, so I'm going to put 17.031 grams of NH3, right? That's the molar mass of NH3. What always goes opposite of the molar mass?
Whatever cancels it out.
1 mole. Why don't you say that with us? The molar mass always goes opposite of 1 mole. You can say it now.
The molar mass always goes opposite of 1.
Okay, that's, I guess, enough participation. Good? How many steps have I done thus far? My first step. Now I should go to my second step, correct?
Calculate.
Now, remember, you always say it's B then T, right? So what number goes on the bottom, 2 or 1? 2. 2 moles of NH3 goes on bottom, and what goes on top? 1 mole of N2. Now let's verify this with cancellation. Did grams of NH3 cancel? Yes? Did moles of NH3 cancel? And you're left with moles of N2, which is what you wanted, so I'll let you do the mathematics of multiplying and dividing here. 4 sig figs in our answer.
56.
Careful. 478.2 divided by 17.031 and 2. I got 14.04 moles of N2. Don't forget that you have to divide by the bottom, and it's got, if you think about it, that's got to go in parentheses. The bottom always goes in parentheses. Don't upset the PEMDAS of this problem. What are we thinking?
Yeah, 14.0.
Yeah, 0.04 sig figs.
Oh.
Cool? Let's look at another example then.
I'll get this one.
Want to make sure you're certainly aware that your homework tonight is over this stuff.
That one.
Let you copy down this question real quick. You can see I've thrown in the molar roadmap towards the bottom here. I want us to use that to help us gauge where we're starting and where we're stopping. Can someone tell me where we're starting this problem? Of what?
Grams of hydrogen.
Okay, so let's draw one line under that because that's where we're starting. And where are we stopping?
Grams of oxygen.
So I like to draw 2 lines under what I'm stopping at, and I'll do an arrow to show me where I'm leaving and then where I'm headed to. Now I heard people say that we're starting at the grams, the mass of H2. So where should I be starting out? Mass of A, mole of B, or mass of B?
Massive.
Okay, so I should start here. And where am I stopping at?
Yeah.
Right, because they want the mass of the other substance, right?
3 steps.
So I've got to draw out a molar roadmap that involves those 3 steps. We're taking mass of H2 to start out. Where's your first stop here? Use your map.
Find the
Okay, one question at a time. Go ahead. Well, if you think about it, it truly doesn't matter, but I like to read things like from a left to right perspective. So I just always assume that I'm starting with A and it going to B. But the reason that I write down A and B in the different, obviously, like variables or letter designations, is because they are 2 different substances. So as long as you keep one substance and the other substance separated, you could go, or the opposite way, it doesn't matter. Mass of H2, and what's your first stop coming down from mass of H2? Use your molar roadmap.
finding the molar mass of
Well,
hydrogen.
let's identify the roads later. We're going to go to moles of H2, right? Correct?
Yeah, but how do you do it?
What would we do that next? Go to moles of what? O2. And then we would jump up to mass of O2. How many steps are we seeing here? 3 steps. 1, 2, and 3. Where's the mass coming from? Well, it says, first off, that you have mass of H2 right there, grams. And it says how many grams of O2. So I know I've got to go from mass of one to mass of the other. So I've got to do this conversion. That's the only conversion factors that we know. Good? You said 3 steps. Let's identify what has to happen in each of those steps. In this first step, what do we have to do? Okay, so someone needs to find the molar mass of H2.
1.
Nope.
007.
Nope. There's 2 H's. Perfect. Like that. And then we always write for the mole to mole ratio B then T, correct? How many moles of H2 do we have in that problem? How do you know 2? How many moles of O2 are we talking about? 1? There's no number written here, so it's understood to be 1. And what do I do to go from moles to mass for oxygen? What does it say on your roadmap to do? Multiply by what? So find the molar mass of O2. I got 31.998. Close enough, it probably wouldn't change your answer. How many steps are we seeing again?
Because I rounded.
So I've got to draw my system. And how many vertical lines are we going to see? 1, 2, 3. Jason, what do I have to put in my top left box? How much? Perfect. Grams of H2. In that first step, because that's where this is step 1, I'm to divide by 2.016. So Brooke, would division go in the top or the bottom box?
Bottom.
So I got to put 2.016 on bottom, and that's measuring the grams of H2 that's in how many moles of H2? 1. Didn't you do a repeat after me a while ago? The molar mass always equals what? I'm sorry, what? 1 mole. The molar mass always equals 1 mole. There's step 1. Step 2 involves putting your mole to mole ratio. Should I put 2 moles of H2 on top or on bottom? Because you always remember B then T, right? So 2 moles of H2 has to go on bottom, and 1 mole of O2 has to go on top. Emily, in the last step, it says to multiply by 31.998. Does that mean you're going to put the 31.998 in the top or the bottom box? I'm sorry? The top? Because multiplication is always in the top, division's in the bottom. This right here is the molar mass, so that's the number of grams of oxygen that's in how many moles? 1 mole. I think y'all probably want to write that down off to the side somewhere, that the molar mass is equal to 1 mole. Probably want to just jot that down. Put an asterisk there, highlight, circle, exclamation point, smiley face. 1 mole is equal to the molar mass. Every time I put the molar mass on this chart, you'll notice it's opposite of 1 mole. Always.
132.
So we multiply the top, divide by the bottom. I'll let you do that. Don't forget PEMDAS parentheses on the bottom.
I think that's right.
92.3, right? Looks like 3 sig figs, give or take, grams of oxygen.
Just the calculator.
I think the key to these problems is recognizing where you're starting, where you're stopping, drawing out the map initially, putting the names of all your roads, which I've done here in red, and then everything else just fills right in. It's like taking a vacation or traveling somewhere. Like, the driving of the car on the road is not the difficult part. I think actually figuring out where you're going to go and how you're going to get there is the difficult part. If you can get this, then you got that. Piece by piece. Yes, ma'am.
Do you want to put 1 mole
Yeah?
How do you know, like, the rule? 'Cause it's
Perfect. Why don't you read the notes? We put an exclamation mark, a highlighter. We did smiley face, sad face, whatever face it was.
like-
1 mole is always equal to the, say it with me.
Well,
Molar mass.
So since this is the molar mass, it's got to have 1 mole opposite equal. Did I do that in another step too? What, did I do that? How many times in the question did I do that? Twice. 1 right there, right? 1 mole was equal to the molar mass there as well.
These questions take a long time.
Well, that's why we have like a homework with like 30 problems. You'll get very quick very soon. Okay, next question. One on your own. I want you to work with a partner, someone around you on this one.
I stole this from you.
You can have it.
That's why this is- you should